morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss about keys topic. So, in this case, we will see introduction part of keys and what are the various types of keys and what are the function of keys and how to calculate the strength of keys we will discuss. So key is a piece of mild steel, so inserted between the shaft and hub. So it is also made of plain carbon steel, and it is a one piece. It may be rectangular or square or circular, so any shape. So we will discuss about in types of keys. It is inserted between the shaft and hub or boss of the pulley to connect these together in order to prevent a relative motion between them. So this is the first primary function of the key. So it is inserted between the shaft and hub to to prevent the relative motion between these two parts. So that's why a key is a machine element. So generally, the keys are used in shafts, power transmitting machines, and the pulleys, in cranes. So wherever the mechanical power transmitting is there, so they're compulsory. This key is you have to use. So the main two functions are there. One is primary function, another one is secondary function. The primary function is to the shaft, the transmitting power, the transmitting torque from the shaft to the hub. So which element is mounted on this shaft. Another one is to control, to prevent the relative motion between these two. So always it is inserted parallel to axis of the shaft. And the keyway is a slot or recess in a shaft and a hub of the pulley to accommodate a key. So here in keys, in keys topic, so two terms are important. One is key, another one is keyway. The key, so already we have discussed, it is a mild steel piece. And the keyway is a slot made on the shaft and on the hub. So sometimes it may be shaft and sometimes in the hub and sometimes in both element shaft and hub. It is a way to accommodate the key. The key is inserted in this slot keyway. So that's why this recess is called as keyway. So the keys are classified into different types. One is Shank Key, and another one is saddle key, and tangent keys, and round keys, and splines. So again, these Shank keys and saddle keys are classified into different types. So what are the Shank keys and what are the saddle keys? What is the difference between these two? We will see. Shank keys, the Shank keys are provided half in the keyway of the shaft and remaining half in the keyway of the hub or boss of the pulley. So half portion inserted into the shaft, another half inserted into the hub. So suppose your shaft is circular shape. So the slot made on this surface of the shaft. Similarly, in hub portion also. So half portion is inserted into another hub portion and remaining half portion inserted in this shaft. Which machine element is mounted on this shaft to carry the to transfer the torque. So that is called as hub or boss. Whereas in saddle keys, two types, flat saddle key and hollow saddle key. Only the slot made in hub only, so not in the shaft, like this. Again, the saddle keys are classified according to their shape. One is flat and another one is hollow saddle keys. So generally, in industries and workshops also, all machines having these two sunk and saddle keys only. The preferable keys are sunk and saddle key. So it gives more strength. The sunk keys are classified into rectangular sunk key, square sunk key. So we will discuss one by one. The rectangular sunk key, the first one is rectangular sunk key. A rectangular sunk key is as shown in figure. So I will show you figure. The proportions of the keys are given. So what are the dimensions of the key? So one is width and another one is length. And the third one, thickness of the key. So length and thickness and width of the key are important in the design part. Suppose you take this rectangular shaped key. So in this, the length of the key and width of the key, this is depth or thickness, T or H. So for rectangular shape keys, the width is equal to, you can take D by 4. What is D here? The D is the shaft diameter. This is shaft diameter. The key dimensions are depends upon the shaft. And the thickness of the key, you can take D by 6 or 2W by 3. Where D is diameter of the shaft and the diameter of the hole in the hub, the key has a taper 1 in 100 on the top side only. It has a taper that also on top side. So the taper value is 1 in 100. In this slide, rectangular sunk key shown. See in this diagram, the taper shown 1 is to 100. So on the taper is available on the top surface. So see here, half portion inserted into shaft and the remaining half will be inserted into hub. So here inside you can identify the dimensions of the key, width and thickness. The length here you can take the length of the key. Here not given. This is the side view. You can't see. So the length is. So these dimensions are important in design part. Next, square sunk key. The only difference between the rectangular sunk key and a square key is that its width and thickness are equal. In square type, the width and thickness are same. Width and thickness, W is equal to T or B is equal to T. T or H, the depth of the key. So you can directly D by 4. 1 by 4th of the shaft diameter. So this is the only difference between rectangular and square. Whereas in rectangular, the width is equal to D by 4 and thickness is equal to D by 6. So this is the square Shank Key. See, in this you can identify this is the length of the key, and this is width, and this is thickness. So keys are comes under the temporary joints. Fasteners are two types. Already we have discussed in earlier sessions. One is temporary, another one is permanent. So whenever you want to remove the shaft and the hub assembly, you can easily dismantle. So whenever you want to replace the any element, you can easily with the help of you can easily replace that element with the help of the key. So that's why the keys are used in the shafts to control to prevent the relative motion between this shaft and hub. If not used key in between these two, so what will happen? After running, after some time, what will happen? So the key and hub, these two material will be contact due to the temperature, to heating. So you can't dismantle, you can't separate these two hub and shaft element. So entire in the time, so what we have to do? So you have to replace these two elements, machine element of the shaft, machine element, and the shaft also you have to replace. To avoid that, so you have to use key. Next, the third one is parallel keys. So the parallel Shank Key may be of rectangular or square section, uniform in width and thickness throughout. These type of keys are called as a parallel key. It may be noted that parallel key is a taperless and is used where the pulley or gear or other mating piece is required to solid along the shaft. So shown in this figure, parallel keys, the taperless. Next key is fourth one is gib head key. So it is a rectangular Shank key with a head at one end known as gib head key. It is a rectangular Shank key, but only thing is difference is it has a gib head at one end. So it is usually provided to facilitate and removal of key. So it is easy to remove. So that's why this head is in the form of gib. So the gib, the dimensions shown in this. See, in this view, clearly given the dimensions of this key. So only the width and thickness and length also same as rectangular key. Only have to calculate extra dimensions of this head. The three ways shown in this figure. Next type is feather key. So a key attached to one member of a pair and which permits relative axial movement is known as feather key. It is a special type of parallel key which controls, which prevents the relative axial movement. So and it transmits a turning movement and also permits axial movement. It transmits turning movement also. In previous keys, rectangular and square keys, not possible turning movement. So the feather keys are shown in this figure. Next one is hood drop key. So the Woodruff key is an easily adjustable key. So see in this figure shown the Woodruff key 3D model. This key is largely used in mission tool and automobile construction. So the shape of the key is the semicircle. It is a piece from a cylindrical disc, so having a segmental cross section. So already they're given in this figure. So you can see here the actual key used in a mission tool. So next classification is saddle keys. Up to now we have discussed about sunk keys. Now these saddle keys are classified into two types. One is flat saddle, another hollow saddle. The flat saddle key is a taper key which fits in a keyway. So you can see here a taper is there. 1:100 and length and width and thickness, as we discussed in previous slides. Whereas in hollow, it is a taper key which fits in a keyway in the hub, and the bottom of the key is shaped to fit the curved surface of the shaft. This one. So it is shaped to fit the curved surface of the shaft. It is used as a temporary fastening in fixing and the setting cams, etc. Next, tangent keys. Next type, the third type is tangent keys. In these keys are fitted in a pair at right angles as shown in figure. These two keys are rectangular keys are placed at right angles. So each key is to withstand a torsion in one direction only. These keys are used for heavy duty shafts. Next one is round keys. So the round keys are shown in figure. I will show you. Are circular in section and fit into holes drilled partly in the shaft and partly in the hub. Some holes made into in a shaft and some other holes made in the hub. So what are the advantages of this round key? So the advantage that their keyways may be drilled and reamed after the meeting parts. So round keys are usually considered to be most appropriate for low power drives. So what are the main important the advantage of this round key is you can so the key is you can drill or you can ream after mating of the assembly also. See round keys are shown in this figure. The shape of the key is circular. So sometimes use a taper pin at one side also. The taper pin inserted into a drilled hole. Next one is splines. Sometimes keys are made integral with the shaft which fits into in the keyways the broached in the hub. Such shafts are called as spline shaft. So generally this type of shafts have 4, 6, 10 or 16 splines. The spline shaft are relatively stronger than shafts having a single keyway. See, in this figure shown spline shaft. These are splines 1, 2, 3, 4. D is equal to the outer diameter of this spline. You can take 1.25 multiply with D. So D is your shaft diameter. This is a shaft dia. B is equal to 0.25 D, the outer dia. Outer dia of spline. This is width of the spline. So in this shown all types of keys the models. See, first one is square and flat, wood wrap, feather key, gib head key, and taper, double. So all these 10 keys we have discussed. Thank you. These are the references I have taken.
Like, share and subscribe. Hit the bell icon for more updates.